Solving nonlinear systems by elimination. Our objectives in this video is to solve nonlinear systems of equations by the elimination method. Let's take a look at the first system that we have here, and we want to solve by the elimination method, also known as the addition method. So recall, to solve using this method, you need to line up your terms or put them in standard form so that you will be able to add the terms. So for example, we have the squared terms. We're going to line those up, the x squared terms. Y squared doesn't have any 1 to combine with, neither is the y by itself. So those are going to be in a column by themselves. And then your constants are going to be, of course, there on the right side. So let's go ahead and rearrange them, align them up. So now we have them lined up, and recall, for the terms that does not have another term to combine with, you can just simply put a placeholder there. Essentially what you're going to be doing is just bringing that term down. You're not going to be adding it. If you want to put a 0 there, you can always do that. So now that we have the terms lined up, let's go ahead and begin our adding process. And as we can see, our x squared terms cancel out. We're going to bring down y squared as well as the y because they don't have a term to combine with. And on the right side, we have 12. Now, our whole goal is in equations is to solve for some variable. So in this case, we're going to be solving for y. So let's go ahead and use the zero factor property by getting everybody on the left side and 0 on the right. So that means that I would need to subtract 12 from each side. Now that we have it in that form, we're going to go ahead and proceed with the zero factor property by factoring it, and then set each parentheses equal to 0 and solve for y. So we can do mental math with that. As we can see, for the first one, we would need to subtract 4, so y would equal -4. On the other one, we're going to add 3, so y would equal 3. And those are our y solutions. So our next step is to plug our solution back into either original equation. I'm going to choose the first one simply because it looks like the math would be a little bit simpler. That into the first one, I'm going to remove the y and replace it with -4. Next, to solve for x, I need to subtract 3 from each side. Take the square root of each side, and x equals the square root of -7. Recall that if you have a negative underneath the radical, that is not a real number solution. That is what we call one of those complex solutions. So in this case, we do not include it in our solution because it's not a real number solution. Let's move on to plugging in a 3 in y's place into that same equation. So removing the y, replacing it with 3. I'm going to subtract 3 from each side, take the square root of each side, and x equals 0. So we do have a real number solution there of 0, 3. And that is our solution to this nonlinear system. So here's what the graph looks like. Your solution, recall, is the points of intersection. And these two graphs intersect or touch right here at 0, 3. No other place do they intersect. Remember, solutions is the point of intersection, which is 0, 3.